everyone, welcome back to my channel. So today we are diving into graph terminology, a fundamental topic in data structures and algorithms. Whether you are preparing for coding interviews or just want to build a solid foundation, understanding graph is crucial. So grab your notes and let's get started. Discuss about what is a graph. A graph is a collection of vertices and edges that link them, and a graph is non-linear data structure. Here we have a mathematical definition for graph. This G for graph, and the V means a set of vertices, and E means edges that connect in vertices. Now let's discuss about types of graph. We have four types of graph: directed graph, undirected graph, weighted graph, and unweighted graph. Here we have directed graph and undirected graph. In the undirected graph, edges have no direction, and in the directed graph, edges have direction like one-way roads. In the directed graph, edges can go both ways, while in the directed graph, edges can go only in the directed path. Here we have weighted graph and unweighted graph. In the unweighted graph, all edges are equal because there are no values on the edges. As an example, a train map where stations are connected without distance values. In the weighted graph, each edges has a weight like cost, time, distance. Now let's discuss about degree of a vertex. Degree in the sense the number of edges connected to a vertex. Here we have an example for graph. Let's check the degree of some vertices. The degree of vertex 1 is 3 because it connected to 3 edges. The degree of vertex 2 is 2 because it connected to 2 edges. The degree of vertex 7 is 1. These kind of vertices called as leaf vertices because it is connected only one edge, and the degree of vertex 8 is 0. These kind of vertices are called as isolated vertices. Because it is not connected to any of the edges. We have two types of degrees, in degree and out degree. These two types are only used in directed graph. In degree means the number of incoming edges. The symbol of in degree is this, and out degree means the number of outgoing edges. The symbol of out degree is this. Here the in degree of V1 is 2 and the out degree of V2 is 2. In this example, the in degree of V1 is 1 and the out degree of V1 is 1. Now let's move on to the next part. Here we have self-loop. Self-loop means the start vertex and destination vertex of the edge are same. In the multi-edge, there are two paths or two edges to go to the same vertex. These are the examples for undirected graph, and these are examples for directed graph. Here we have two types of graph, simple graph and multigraph. Simple graph means there are no any self-loops or multi-edges. In the multi-graph, it has self-loops and multi-edges. Here we have two equations of directed graph and undirected graph to find the maximum number of edges in a graph. The equation of directed graph is n into n minus 1 and the equation of undirected graph is n into n minus 1 divided by 2. Let's imagine we have a graph with 10 vertices. The n means the number of vertex. So let's find out the number of edges in directed graph. Here we have 10 vertices, so 10 into 10 minus 1. Then 10 into 10 minus 1 is 9 equals 90. This is the number of edges in directed graph. Let's find the maximum number of edges in undirected graph. Let's solve this. N equals 10. 10 into 10 minus 1 divided by 2. 10 into 10 minus 1 is 9. 10 into 9 divided by 2. 10 into 9 is 90 divided by 2. The answer is 45. This is the maximum number of edges in undirected graph. So this is the way how we can find the maximum number of edges in directed graph and undirected graph. Now let's discuss about the walk, trace, path, circuit and cycles. The first one is walk. Walk is a sequence of vertices and edges that can be repeated. The closed walk is the subpart of walk. In here, the walk is end with the starting vertex. Here this is a walk. Now let's write a closed walk. The starting vertex is D. D and next D to C and C to A and A to B, B to G and G to E, and the walk is end with B. As you can see, the ending vertex and the starting vertex are same. So this is a closed walk. Our second type is trail. In the trail, the edges cannot be repeated. Here we have an example graph. There are no repeated edges, so this is a trail. And our third type is circuit. In the circuit, it should be a trail and it should have a closed walk. In this example, this is not a circuit because this is not a closed walk. So we have to go to the vertex D. Now this is a circuit because the starting vertex and the ending vertex are same. Our next type is path. In the path, the vertices cannot be repeated. In this example, there are no repeated vertices, so this is a path. And our last type is cycle. The cycle should be a path and it should have a closed walk. So, in a path, the vertices cannot be repeated, but a cycle means a closed walk. So in a cycle, the starting vertex can be repeated as the ending node. So in here, this is not a cycle because this is not a closed walk. So we have to go to the vertex E. Now this is a cycle. So today we learn about graph terminology. Thank you for watching. See you in the next video. Bye.